Howdy, y'all. It is Miss Kosh or Aunt Carrie, depending on how you know me. I promised my cousins that I would make a video about SAT constants. I think that's what they call these problems. So we were hanging out on Easter and we found a couple. I screenshot a couple problems and I'm going to work these and see. I haven't really worked them yet, but we're going to see if we can make some sense out of these three. And if there are others, Susanna, let me know. Okay, send me more. Okay, so let's start with this first one. Well, I did read through them a little bit. And what I did notice on between the three of them is you're going to want to start with whatever information you're given and kind of, when they tell you something, they tell you that for a reason. So like on this one, they're saying P is a constant. Okay, that's great. The part that really matters is that there's no solution. Okay, and so, well, how do we get something to have no solution? We would get something to like 0 equals 84. We would get a false statement would give us no solution. Now, if we got something like 84 equals 84, then you have infinitely many solutions. And so that would be, there's no distinct solution, but there are infinitely many that would be accurate for that. Okay, so how do we then go about making something to be false so that there is no solution? What I see is, since I've got this 84 over here, I'm just going to kind of leave that alone. I want to see how I can make this negative 3x equal to this 21 px. And so if what I want is negative 3x plus 21 px to equal 0. Okay, actually, we don't even really need the x's. So I want negative 3 plus 21 p to equal 0. When I do that, I can add 3 and then divide. And 3 over 21 is equal to 1/7, and that was an answer choice. The other thing would be to just plug these different things in and see what happens. So as a math teacher and not an SAT prep person, I prefer to do the math and then verify where it is on the answer solutions. But with the SAT, if you want to go straight to the answers and plug them in and see what happens, knock yourself out. That's just not pure math, but anyway, it's fine. Okay, so negative 3x, if I did that plus 21 times 0x equals 84, well, you couldn't see what I was underlining, that goes to 0, and so I get negative 3x equals 84, which has a solution. Okay, so that's no good. I can do, let's see, let's get rid of that. I can do, let's verify with our 1/7. If I do that, then I have negative 3x plus 3x is equal to 84, which gives me 0 is equal to 84. Therefore, that's our no solution. Okay, I think my eraser is too thick. Anyway, let's try the next one. What was the next one? 4/3. So if I do 4/3, that's a 3, pretend. Okay, then I see 7 times 4, I see 20. I see negative 3x plus 28x is equal to 84. I can solve that. 25x, so it's 84 over 25, but yeah, that wouldn't work for us. The last one I said was 4. So if I plug in 4, okay, the eraser's too thick. And oh, what did I do? My apologies. Okay, likewise here, I'm going to get something x equals 84, and it would have a solution. So we were correct in what we did right there. Okay, the next one. In the equation above, k is a constant. If x equals 9, what is the value of k? So this one I think is, I don't know if this is one that would cause you trouble or not, but it's kind of, I think it's relatively straightforward. It's more straightforward than the previous one, in my opinion. We just need to solve. And so when I see the square root, I undo square roots by squaring both sides, and then I can subtract. And there we go. That to me was straightforward. Plug in. So what they had done is they had given you a value. So let's plug it in and then see what we can do with ourselves. That sounded funny. We can. I was homesick. I'm sorry. Here we go. Okay. And the next one, let's see. In the expression above, a is a constant. If the expression is equivalent to bx, where b is a constant, what is the value of b? Okay. Okay, so here's what I see. They're saying this is equal to bx, which means we would have 0 times x squared, and we would have 0 for our c value. So if you think of like a quadratic, we're used to seeing this maybe, x squared plus bx plus c. In that scenario, our a and our c are both equal to 0. So we need to manipulate things so that stays true. So what I would probably do is FOIL, and so I have 4ax squared when I go this, okay, and then I have minus 4x plus 4ax minus 4 minus x squared plus 4x, nope, just 4, is equal to bx. Okay, so let's see what happens. My x squared, I just have 4, I have 4a minus 1 times x squared, since this term and this term have an x squared. And then I have my x term. Let's see, if the expression is equivalent to bx, where b is a constant, what is the value? Oh. Well, okay. I'm not sure I like their problem, to be honest with you. Negative 4, then I have a negative 4. So let's say plus, let's do it this way. Let's say plus, we'll have a negative 4 and a positive 4a, and that's all being, so these two I was putting together. And then I see a negative 4 plus a 4 is 0, and so this is bx. If the expression is equivalent to bx, well, what I think that means is that a has to equal, oh yes, okay, I'm not wrong. What, because, that's funny, because this has to go to 0, I need 4a minus 1 to equal 0, so then 4a would equal 1, therefore a would equal 1/4, super, okay, but what they're wanting to know, that we knew that had to go to 0 because we said back up here that it was going to go to 0, because it was only equivalent to bx. And so now I can take this and say negative 4 plus 4 times 1/4. It would be, this times x would be equal to b times x. Well, there, I don't need to write the x's. So I see a negative 4 plus 1 is equal to b, which is equal to negative 3. If I wanted to plug in the values, that would not be helpful. Because we need to solve for a, and the a isn't one of the choices. They're not giving you choices of a. So the trick on this, or not the trick, but the thing that we're needing to use the most is that it's equivalent to bx, where b is a constant. So this bx, because it's only equivalent to bx, what we had to realize is when I expand this out, it's going to be something quadratic, which is typically in the form ax squared plus bx plus c. If it's only equal to bx, that means this a has gone to 0 and the c went to 0 also. So that helped us solve for a. All right, these were the 3 that I found online. I hope that was somewhat helpful. Let me know, Susanna, if you have particular questions and you want me to look at them. All right, like, subscribe, comment, and go practice.